Intercept. So in x-intercept, let's recap because we've heard of this stuff before. And I'm recording, so please make sure you're not talking so the video can hear me, not you. Sorry, I'm the important one today.
Oh, snap.
Alright. What is an x-intercept? Is it a point? Is it a line? Talk to me.
It's a line. What is the point?
It's a point. It's the point when I cross over which axis? X-axis. And then a y-intercept is when I cross over the y-axis. Okay? So an x-intercept is always something comma something. Okay? What is always the y value of an x-intercept? If you were laying on the x-axis, are you ever going up and down?
No.
No. So your y value is always going to be 0 because you don't actually go up and down. So your x-intercepts are something comma 0. Okay? Always. It's a point, so we've got to write it as a point. Whereas y-intercept, what do you think is the only thing that changes when we get to y-intercept? It should be 0, comma, something. Okay? They flip. Now, to find an x-intercept with these rationals, this might be something when we start building our flashcards. You set the numerator equal to, what do you think I'm going to set? Set the numerator equal to 0. That's different from our domain restrictions because we're setting now the denominator for that. But now we are setting the numerator equal to 0. Okay? So let's do our first example. We've done all of these. So negative 2x plus 4 over x minus 3. We've already done this one a few times on the other pages. We took out a negative 4. Left was x minus 2 over x minus 3. Now, is there a hole in this one? No. If you have a hole, it's going to affect your x-intercepts, okay? Remember, after you find a hole, you use that simplified radical to answer everything else, okay? But we don't have a hole, so I can just go ahead and set my numerator equal to 0, okay? So I'm just looking at this guy. If I set negative 2, x minus 2 equal to 0, how would I solve that? How would I get rid of the negative 2? Nope, what's that bar mean? Divide, right? I'm getting rid of it. I'm getting x by itself. 0 divided by negative 2 is just going to give me, it's not a trick question, I promise. 0 divided by something is just 0. The last step to solve for x is what? Add 2, right? It's what we've been doing a million times, right, with the denominator. So x equals 2. But if I want to write this as an x-intercept, it's going to be 2, comma 0. All I did was solve for the x. All I did was set the numerator equal to 0, solve for x. That's all I did. We've done this before. Look, did the negative 2 have anything to do with telling me what x was going to be?
No.
No, I just look at really the x minus 2 and it's positive 2. We've done this a million times with the denominator, okay? So that means since x is 2, when I set my numerator equal to 0, my x-intercept is at 2, comma 0. That's what I'm filling in that blank. Yeah, we're only looking at the numerator for x-intercept. That's it. Okay, that's the rule. Yes? Now, let's look at number 3. We have done this one before. X stays the same. We had a GCF of x, and it leaves me with x plus 1, right? Do I have a hole with number 2?
Yeah.
Yes, I can get rid of the x's, right? What's left over? If you have a hole, to find everything else, you've got to make sure you simplify, right? What goes at the top now?
1.
That's a 1, I promise. So, I am setting what equals 0 to find my x-intercept? The numerator. But, that's kind of weird. Do I see any x's in the numerator?
No.
Is 1 equal to 0?
No.
Not last time I checked, right? So are we going to have an x-intercept if there's not actually an x in the numerator?
No.
So my x-intercept is just going to be,
0?
no, not 0. That means there's something there. It's going to be
None.
none. 1 cannot equal 0. Okay? 1 cannot equal 0. Now let's do the homework question we just did really quick, okay? Actually, no. I'm going to do 3. That keeps me with an x-intercept. This one we factored out a 2, right? We've already done this one, that's why I'm not going through each step on how to factor this. The bottom factors as well, and it will be, y'all agree?
Yeah.
And then the top, who remembers? If you take out a 2, it's -2 and 1. I'm sorry, my God. Am I boring you? I'm bad. Alright, do we have a hole for this one?
Yeah.
Yeah, what simplifies? So, I'm left with 2x plus 1 over x plus 3. Do you see why it's so important to check for a hole every time? Because did I get rid of it? If you just went ahead and set your numerator equal to 0, how many x-intercepts would you say you would have had? 2. But we don't really have 2. We actually only have how many? 1. So if I set this numerator equal to 0, what is x going to equal? The 2 has nothing to do with it. So if I set x plus 1 equal to 0, what do you get? -1. So what's my x-intercept at? If x equals -1, it's at -1 comma what? That is it. It is just like what we do with denominators, but instead we are doing it with what? Numerators. On which one? Which part? I set the numerator equal to 0, so that x plus 1, if I set it equal to 0, would give me a -1. We have a hole. If you have a hole, you are looking at the simplified version for every characteristic after you find the hole, okay? The only exception is your, what? The domain, right? Domain, I don't have to worry about simplifying it to find it, right? But everything else that you find after domain has to deal with this simplified version, okay? Yes? Yes. We do it in order for a reason, and on your test it will be in order for a reason, because they all have to build up with each other. Who's always going to come first? Domain, because you have to do that before you simplify, okay? So, again, Jonathan, I factored simplified. I have a factor in common, x minus 2. So I couldn't set my numerator equal to 0 because there is a hole. Once I simplified it, setting the numerator equal to 0. You could do it the long way. You're just solving for x. That would be dividing by 2. X plus 1 is equal to 0, and then you subtract. That is how I got -1 the longer way. It's still going to be opposite of wherever you have an x. Okay? Good question. All right. Flip to the next side. Y-intercept is kind of similar. These are two of the easiest ones to find. So x-intercept we did what? Set what? Numerator equal to 0 after I had a what? If I have a hole, okay? Now, the y-intercept we just talked about before is going to be 0 comma something. It switches, right? To find this, and what you're going to have to remember what do you think I'm plugging in 0 for? If I look at this ordered pair, where is 0 at? This is always x comma y. So where is 0 for what value, x or y? Yeah, so I plug in 0 for all the x's, okay? plug in 0 for all the x's. Something kind of interesting ends up happening. So I've simplified, I've done all that, but if I even start from the beginning, if I do negative 2 and plug in 0 for x, what's going to happen to negative 2 times 0? It's going to become what? 0, right? Negative 2 times 0 is going to give me, I'll show you what I'm talking about. I'm plugging 0 for anywhere that I have an x, right? This is going to become 0 plus 4, which is just what? 4, right? 0 minus 3 is what? So my y-intercept is at 0, comma, negative 4 over 3. That's my y-intercept. Where did you see those 4 over negative 3 before? Did we see it in this problem somewhere?
Yes.
If I cover everything that has an x, what's left over?
4.
The answer, right? What are those numbers called without variables? They have a special name. You are just looking at your constants, basically, okay? So let's look at number 5. What are my only constants? Negative 4 over negative 6. Negative over negative gives me what? Positive, and 4 over 6 would reduce to what? 2 over 3, right? Not negative. Negative over negative gives me a what? So let me check. If I do 2 times 0 squared minus 2 times 0 minus 4 over 0 squared plus 0 minus 6, all of this is going to become 0, so in the numerator I'm still only left with, this is 0, this is 0. 0 minus 4 is negative 4. 0 plus 0 minus 4 is, or I mean minus 6 is going to be negative 6. So you're really only looking at your constants, okay? Anywhere you plug in an x is going to become what? 0, because you're plugging in 0 for it, right? So you're only going to have what's left over, okay? So how would I write that? So we simplified negative 4 over 6 to what? 2/3. How would I write that as a y-intercept
It
though?
would be 0.
0, comma,
I want to change coach.
2 over 3.
And that's the answer.
That's the answer for my y-intercept, okay? So these are these rules that I'm writing at top that you have to know. That's why flashcards are going to be really,
I'm straight, coach.
really,
I'm straight.
really to the really squared important, okay? Really important. All right, let's look at number 3. How would you do number 3? Is there any constants? So if I plug in 0 here, what's going to be in my numerator? What's going to be in the denominator if I plug in 0? So the y-intercept is at 0, comma, boom. What about number 4? What are my constants left over? Negative 1 over negative 12. A negative over a negative is going to become a what?
Positive.
So the y-intercept is at 0, comma, 1 over 12. Where are the constants in number 2?
4 and negative 12.
So that would be what? If I simplified that, 1 over negative 1/3. So the point is 0, comma, negative 1/3. Y'all try the last one. See if you can find 6. See if you can find 6 while I upload this.
Is it going to be 1?
Not 1. Not just 1.
Negative 1?
Maybe.
Okay.
Let's see whatever everybody else gets.
I got an answer.